Hi, this is Mrs. Huntley. This is Module 2, Lesson 14, more on the angles of a triangle. You should be on page 92 of your module, and your essential question for this lesson is what other angle relationships exist with triangles? So what you have here is a discussion about a rectangle. So let's take a look at this rectangle really quick. Whoops, let me get rid of that line. So what do we know about rectangles? All four angles here are 90 degrees. Opposite side lengths are equal in measure. When you see marks like this and they match marks on the other side, that means they're equal length. So now we're going to draw a line from A to C to create two triangles. What do we know about these two triangles? Well, first of all, they both have a 90-degree angle, so they're both right triangles. They both have congruent side lengths, including the hypotenuse. So we know that both triangles are congruent because we've got all side lengths the same, and we've got our measurements the same, our angle measurements the same. Furthermore, if I copied this triangle onto a transparency and then I rotated it around and actually I'd have to rotate and reflect, they would map onto each other and they would map perfectly. So what are we trying to prove here? We're trying to prove the triangle sum theorem yet another way. So if our rectangle has four 90-degree angles, I could multiply 4 times 90, and I know that there's 360 degrees in all four angles of my rectangle. Since a triangle is half of a rectangle, and I know that there's a total of 360 degrees in my rectangle, I can divide that by 2, and I get 180 degrees. So I know that there's going to be the interior angles of half of the rectangle is going to be 180 degrees. So it's just yet another way of proving the triangle sum theorem. So let's move on to what this lesson is about. And this lesson is about the exterior angles on a triangle. So again, remember interior is inside, exterior is outside. Okay, you can label yours up if you want to. I'm actually going to remove that. I just wanted to show that to you because my drawing is going to get a little bit messy if I leave those there. But exterior is outside of your triangle and interior is all this area inside the triangle. So let's make sure that we understand the difference between interior and exterior here. So let me go ahead and get rid of that so that I can move on with my drawing. I'm actually going to number my angles because I proved to you yesterday that I get tongue-tied when I'm trying to say my angles using the 3 letters. We're going to use the 3 letters, but we're also going to use the numbers. So I've got that as 1, 2, 3, and then this outside angle is 4, this one 5, and this one 6. So the first thing that it asks us to do is to name an exterior angle and the related remote interior angles. Let's talk about the word remote. When you're using a remote, maybe you're operating a toy car, or you're operating a drone, or maybe you're trying to change the channel on your television. When you're doing those things, you're not right next to the drone or the television or whatever it is that you're trying to operate. You're a distance away from it. So when we're talking about remote, we're meaning that it's going to be a distance away from whatever it is we're looking for. So an exterior angle is going to be an angle that's going to be on the outside. Let me get a highlighter real quick. So this is the exterior angle that we're going to talk about first. That angle, if I'm labeling it with my 3 letters, is going to be ZYP. So angle ZYP. We're also calling it angle 4, just so you know exactly where we're looking. So the related remote interior angles, so my remote interior are going to be the ones that are opposite from it. So they're going to be over here and here. Okay? I can't flip back and forth fast enough. So that's going to be angle YZX, which is angle 2, and angle YXZ, which is angle 3. Okay? So now we're going to look at a straight angle. This is my straight angle that I'm going to focus on right now, okay? That is my straight angle, and that's angle X, Y, P. X, Y, P, okay? Now I know that a straight angle equals 180 degrees. I know that so if I'm adding together the measure of angle 1 here and the measure of angle 4, so the measure of angle 1 plus the measure of angle 4, I'm going to get 180 degrees. I also know if I add together the measure of angle 1 plus the measure of angle 2 plus the measure, of angle 3, I'm also going to get 180 degrees because that's the interior angles of my triangle, and that's going to sum to 180 degrees. So if the measure of angle 1 plus the measure of angle 4 equals 180, then the measure of angle 1, the measure of angle 2, and the measure of angle 3 equals 180, then I know the measure of angle 1 plus the measure of angle 4 is going to be equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. That's that whole transitive thing. If these two things equal 180, then those two things are going to be equal to each other. So what is the common link here? The measure of angle 1. So if I remove the measure of angle 1 from both sides, it's showing me that the measure of angle 4, my remote exterior angle, is going to be equal to the two measures of I'm sorry, I said remote. I meant the exterior angle is equal to the measure of the two remote interior angles. So measure of angle 4 is going to be equal to the measure of angle 2 plus the measure of angle 3. Hopefully that makes sense. The next example asks you to name a second exterior angle and the related remote interior angles. So the next exterior angle, let's just call it by its number. The next one is going to be angle 5. That's my exterior. And the remote interior angles are going to be angle 3 and angle 1. Why don't you go ahead and name the third exterior angle and the related remote interior angles, pause the video, and come back and see if you're correct. Okay? Next it says, show that the measure of an exterior angle is equal to the sum of the related remote interior angles. So what I want you to do here is restate what I did on the other page, kind of in your own words. Restate this whole idea in your own words. I'm not going to do that for you. I'm going to leave that to you to do. All right, so example 1, find the measure of angle X. That's the exterior angle. Here's our triangle, and that's the exterior angle here, X. And they're asking us to find what measure that is. So what I'm going to do is take my remote interior angles, 14 plus 30. 14 plus 30 is 44. So I know X is going to equal 44 degrees. Example 2, same thing. They're asking me to find that remote exterior angle. So I can add together, I'm sorry, I keep saying remote exterior. That's not what I'm looking for. I'm looking for the exterior angle. So I'm going to use the two remote interior angles, add them together, and that'll give me my exterior angle. So go ahead and pause the video and see if you can add those together for me. Yes, that is the bell, and people are going to be starting to come in my door any second here. So this one is going to be 76 degrees. Example 3, they're asking us to find this angle. Now don't be fooled here. This is a straight angle. I know a straight angle has 180 degrees in it. So I don't need to add my two interior angles together. I need to take 180, subtract 121, and I'm going to get that missing angle there. So that is going to be 59 degrees. Okay. This next one, I can attack in two different ways. I can figure out this angle, and then I can take 180 minus 129, and you don't have to write this down yet until you decide if this is the way you want to do it. So I can find out that this angle is actually 51 degrees. And then I could take 180 again, and I can say 180 minus 51 minus 45 is going to give me 84. So this one's going to be 84 degrees. That's one way I could do it because I know those interior angles, 45 plus 84 plus 51 is going to equal 180. And I have a straight angle here, so I know that's 180, and I know this part is 129. So if I take that away, it gives me this part. That's a fine way of attacking this problem. However, there is an easier way. I know this plus this, so x plus 45 is going to equal 129. Because 129 is my exterior angle, and that's equal to the two remote interior angles. So now I just have to subtract 45 from both sides, and x, again, is going to equal 84. I get the same answer either way, so it really doesn't matter to me which way you attack that problem. What I'd like you to do right now is go ahead and pause the video and do the next on your own problems that are on page 94 and 95. Actually, going through, just do 80, the rest of the problems on 94 and 95. Pause the video and then come back to see if you're right. Okay, so number 5, x should equal 117. Check your work. I will show you how to do it in class tomorrow if you have the wrong answer. Number 6, x should equal 111. Number 7, x should equal 101. Number 8, x should equal 145. That is going to conclude this lesson here because people are trying to walk in. So I'm just going to summarize super quick. We've learned another proof as to why the interior angles of a triangle are equal to 180 with respect to a triangle being half of a rectangle. We also learned the definitions of exterior angles and remote interior angles. And we learned that the sum of the remote interior angles of a triangle is equal to the measure of the related exterior angle. Have a good night, and I will see you tomorrow.